All right, this video is going to be on how to find the inverses of exponential and logarithmic equations. All right, so there are two different contexts where we use inverses in this unit, and one context is just to take a simple equation that's written in log form or written in exponential form and then convert it to the other form. So I'm going to go ahead and say this is just converting. So for our first example, if we had the exponential form 3 to the 4th equals 81, then we're going to go ahead and we want to convert it into log form. Then we're going to do the inverse of exponential form, and that's going to convert it into log form because logs and exponentials are opposites of each other, exactly the same way that we have addition and subtraction. We would say are opposites, multiplication and division are opposites. Those are operations that undo each other. So if I want to convert this into the other form, then I'm going to go ahead and kind of do that opposite operation. And the opposite operation of an exponential function with a base of 3 is a log with a base of 3. So what I'm going to go ahead and do is I'm going to log base 3 the left side, and I'm going to log base 3 the right side. So if I write down what I just did, I have log base 3 of 3 to the 4th equals log base 3 of 81. And because they're inverse operations, the log base 3 and the base of 3 cancel out. And so when I convert this, I get 4 equals log base 3 of 81. All right, here's another example. I'm going to use 81 again. I'm going to say 81 equals 9 squared. So this time, the base of the exponential piece of it is a 9. And so for this one, I'm going to log base 9 each side. So whatever the base is, that tells you what log base to use. So now I'm going to go ahead and write what I have. I have log base 9 of 81 equals log base 9 of 9 to the 2nd power. And the log base 9 and the base of 9 cancel out. So that means when we convert it from one form to the other, we get log base 9 of 81 equals 2. And it also goes the opposite way. So if I started off with something that was in log form, I could say I have log base 2 of 32 equals 5. So then to convert it into exponential form, I want to start with the base, and this has a base of 2. So I'm going to make it an exponential on each side. 2 to the log base 2 of 32 equals 2 to the 5th. So I'm just going to go ahead and write that really clearly in my notes so that later on I know exactly what I was thinking. So 2 to the log base 2 of 32 equals 2 to the 5th. And what happens is because these are inverse operations, the log base 2 and the base of 2 cancel out. And so I just get 32 equals 2 to the 5th, which is true, right? 2 to the 5th is 32. All right, and one last example. Let's say we have 2 equals log base 5 of 25. So again, to convert this into an exponential, we want to undo the log, and the log has a base of 5. And so I'm going to put a base of 5 on this side and a base of 5 on that side. So I have 5 to the 2nd power equals 5 to the log base 5 of 25. So my base of 5 and my log base 5 cancel out. And I end up getting 5 squared equals 25. So to convert back and forth these simple equations, you just have to do the inverse operation. So if you have a log equation, you're going to add an exponential base to each side. If you have an exponential problem, then you're going to do a log to each side. All right, the other place where we use these inverse operations is when we're actually trying to find the inverse of a function. So I'm going to go ahead and write that next. Inverse of a function. All right, so for the first example, we're going to have y equals 2 times 3 to the x plus 1 minus 4. So when you're finding an inverse, the very first thing you do, if you guys recall, is you trade the x and the y coordinate. Well, I guess not coordinate here, just the x and the y. If you were dealing with points, you would change the coordinates, but we have an equation. So I just traded x and y, and then I need to undo each of the numbers that are happening to the y value so I can solve for it. So the first thing I'm going to do is see if there's a number I could add or subtract to move it over to the other side, and there's a -4, so I could just add 4 to both sides. So I have x plus 4 equals 2 times 3 to the y plus 1. Then to get closer to y being alone, I can see if there's a number I could multiply or divide to the other side, and I can do that with the 2. So I will go ahead and divide by 2. And now at this point, to be able to get into the exponent, I need to get rid of a base of 3. And the way that I do that is I log base 3 on each side. So I'm going to go ahead and log base 3 on the left side and log base 3 on the right side. And so log base 3 and the base of 3 cancel. And what I have left is log base 3 of x plus 4 over 2 equals y plus 1. And so my last step is going to be to go ahead and subtract that 1 over. And then if you guys recall, we want to make sure that every time we find an inverse that our final answer has the inverse notation. So that would be the inverse function if this is the original function. And anytime you see a problem where the original function has an exponential equation, then that means that your inverse function should have a log equation. All right, let's go ahead and do one more example. And we'll definitely practice these tomorrow because I know they can be a little tricky. So with this one, we're going to start with y equals 1/2 log base 2 of x plus 3 minus 1. I'm going to actually put a little negative in front of here. -1/2. There we go. Okay. So first thing I'm going to do when I find an inverse function is I need to trade the x and the y. And then next I'm going to see if there's a number that I could add or subtract to the other side, and I can add a 1. So I have x plus 1 equals -1/2 log base 2 of y plus 3. And then I'm going to see if there's a number that I could multiply or divide to the other side. And whenever you're getting rid of a fraction, it's a little bit easier to multiply it. So if I multiply the left side by -2, -2 times -1/2 is just 1. And if I put a 1 in front of an equation, it's kind of like not having a number there at all. So I'm going to multiply the right side by -2, and I'm going to multiply the left side by -2 as well. And I'm careful that when I multiply it on the left, I'm going to make sure to distribute that -2. So the -1/2 and the -2 multiplied, and they canceled each other out. So this gives me -2x minus 2 equals log base 2 of y plus 3. And now at this point, for me to get to the y, I have to undo a log base 2. And so what I need to do to get rid of that log base 2 is I need to put an exponential base of 2. This step right here, when you put like an exponential base of 2, it's called exponentiating each side, which is kind of a weird word. You don't have to call it that if you don't want to, but I think it sounds kind of cool. So exponentiating both sides. So on the left side, I have 2 to the negative 2x minus 2 equals y plus 3. And now all I need to do is subtract the 3 to the other side. So 2 to the negative 2x minus 2 minus 3 equals y. And then I always want to make sure that my final notation is the correct inverse notation and that it matches the original problem. And so I'm going to put y inverse, and then I am officially done.